So the next unit that we're going to cover is momentum and impulse. And this little unit is going to be a fairly quick one, but still an important one. So kind of the nice thing about momentum and impulse is this is one of those things in physics, at least I feel, that a lot of people have a correct natural idea of anyway, unlike things like acceleration and action-reaction forces. There's not too many mind games that I could play to you guys in this chapter. So to start off with, let's go ahead and define these two things. Momentum, you guys are probably familiar with already. Impulse, maybe not so much. So when we talk about momentum in physics, the way you can think of it is momentum is a measure of inertia. Okay, momentum is a measure of inertia. And the more momentum an object has, kind of the more it wants to keep on moving, in that same velocity, the harder it is, let's say this, the harder it is to change its motion. So to calculate momentum, what we say is P, and yes, P stands for momentum. It comes from the word impetus, and is already used for something else in physics, which we'll get to shortly, and M is used for mass, right? So we use P for momentum. And the other thing to note about momentum is that it is a vector quantity. Okay, so we will once again, after this unit of energy and work, which were not vector quantities, we're now going to be working with something that is a vector. So we have to break out our X and Y components and all that cool stuff. So momentum is equal to the mass of an object in kilograms times the velocity it has in meters per second. And momentum will have the same direction as the velocity. Okay, so whatever direction the velocity goes in, that's the direction the momentum goes in as well. So this is the first equation, the big equation in this chapter. P is equal to mv, and that P stands for momentum. Now, what is this thing called impulse? So impulse is the change momentum. Okay, so impulse is the change in momentum of an object. Change of momentum. So if the velocity of an object changes, and that could be a change in direction or a change in magnitude, then its momentum changes as well. And to do that, we have to, as we already learned, we have to exert a net force, a net external force, and that will change it. So the way that we calculate impulse, a lot of times impulse is summarized with a J, and I'm sorry, I don't know why on this, why impulse is abbreviated as J. So impulse, and the impulse is equal to the force applied to an object. So the impulse will be, the change in momentum will be the same as the direction of this force, times the time over which the force acts. So this is time in seconds. Okay, and this is force in newtons, and this impulse. So let's back up a little bit and talk about units here. So momentum doesn't really have its own units. It doesn't have anything like equivalent to the newton for forces. So the units for impulse will be a kilogram meter per second, and the unit of impulse, you would think, is a newton second, but keep in mind that a newton is a kilogram meter per second squared, mass, acceleration, times a second, and you actually get the same thing. How awesome is that? A kilogram meter per second. So this impulse, we could either calculate it and look at the change momentum that an object undergoes. So this would be the mass times the change in velocity. Or, so this is one way to calculate it, or just kind of, if you're sometimes you're given this change in momentum, or you have the force of an object times the change in time. So one of the conceptual things that comes up with impulse is this idea of change momentum. And say you jump from the top of a table, as people tend to do. So you jump to the top of the table. From the time that you first could jump off of things, you knew that when you hit the ground, you had to bend your knees. Like I said, you guys kind of have an instinctual understanding of this stuff already. And so the question is, why do you bend your knees? Well, your change of momentum is going to be the same no matter what. Your mass is going to be your mass. Your change of velocity is going to be the velocity right before you hit the floor, and it's going to change to 0. So you're going to have the same impulse. You're going to have the same change of momentum. Now, you can either do that over a long period of time, which makes the force smaller, or you can do it under a very short period of time, which makes the force greater. And to minimize the damage to yourself, you lengthen the time. By bending your knees, you lengthen the time over which this momentum changes, which makes the force less, and then you don't get hurt. And the same thing happens with, airbags in cars, right? When you get in a car accident, your body's traveling with the car. It's going to come to a stop. It's going to change its momentum. Now, what the airbag does is it lengthens the time over which your body, your face, whatever, changes momentum. Your face can either hit the steering wheel and change momentum very rapidly with an extreme amount of force, or it can hit the airbag and change its momentum over a longer period of time with lesser force. Okay, so yeah, those are the two ideas of momentum and impulse. Like I said, it's not that complex. The other thing that I wanted to talk about is this graphical representation of impulse. As I said, on AP Physics 1 exam, they love graphs. They love graphs. And so let's talk just really quickly here about how to represent the impulse, or how to get the impulse from a graph. And so the graph that we would use, so again, I'm going to write this equation here. J is equal to force times change in time. And again, if you have this idea of integrals, then you can kind of see how if we plot force versus time, force versus that change in time, and it does whatever it does, then if we take the area under this graph, okay, so the area under the graph, that's going to be our impulse. Okay, so the area under a force versus time graph is the impulse. It's equal to the impulse. Now, something that's very similar to this, which we just had the last chapter and you have to watch out for, especially on the AP Physics 1 exam, is this force distance. Remember, we were saying force and distance, and if you take the area under that, you don't get impulse. You don't get change of momentum. What do you get? You get work. Okay? So make sure you watch your horizontal axis here, guys. Don't confuse these two graphs. One, the area gives you the impulse. The other, the area gives you the work. Okay, so that's pretty much it for this video, and we will work on this more in class.